Okay, so this is AP review class number 2. We worked on pseudocode. We're looking at your pre-AP review book. We're looking at page 49 and 50. And that's where it starts talking about what pseudocode is, because APCSP doesn't require us to teach a specific language. When they talk about codes in your on your AP exam, they write it in a made up code system. So there are two different formats they're going to show you. They're going to either show you a block base, which will look sort of like Scratch. It might just be like this. It might just be ovals with words inside of them. But again, very easy to, sort of understand what they're going through. Or they might talk about a text-based format that looks sort of like C. Maybe it have the same components. We know if there's like a hashtag up here and an include, there might be a library that's being included in the program that has stuff in it that we might use. We know that semicolons mean the end of a statement. The return 0 just means that you ended your program. When you see something like this, where there is a double symbol, either a double less than symbol, a double hash, a double slash, a double star, that's usually an indicator that there's a note or a comment in the program. So that's not going to be part of what's going to be run by the program, but it's just a comment about what maybe the next component or the next part of the program does. We're going to look in your AP review book. When you're looking your AP review book, make sure you pick up the one that says multiple choice questions and topic reviews in preparing for the APCSP. And if you look on page 51, we start looking at basic pitfalls that happen when you're doing a multiple choice question. So a multiple choice question could look like something like this, where they give you like pretend code here, where step 1, step 2, step 3, step 4. And if they have a question something like this, which of the following algorithms displays the correct distance for all possible values of n1 and n2, num1, num2 stands for two numbers. Okay, not crazy a variable notation. It's going to be used on your AP notation for variables. The notations for programs are going to be pretty self-explanatory. So here we have two numbers, and then the distance between the two numbers on a number line, for example. So 5 and 2, and the distance between the two would be 3. The distance between 1 and 8 is 7, yada, 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 yada. So as we read through these, which one of these makes sense to explain what's happening using num1 and num2 to predict row 3? All right, if you guessed B, you're right. Subtracting the num1 and num2 and storing the results as a variable called difference, and then displaying that difference, but after you take the absolute value of it. So the absolute value meaning the positive output between the two. The mathematics in APCSP are not advanced mathematics, except for maybe one topic, which we're going to spend some time on in class, okay, which is modules. The arithmetic is basic because you're not permitted to use your calculator. So the only thing you're going to bring there is to the exam date is your number 2 pencils and a smile. So the calculations that would need to be done should not be rigorous, should not be complex. You should be able to find the difference between these two numbers and determine the answer. Okay, things that you should know when you're looking at a pseudocode question. Make sure you're answering the question that's presented to you as opposed to the question that you think is being presented to you. Some of us don't read the question when we get pseudocode. We just look at the pseudocode and we just figure out, oh, what's that code going to do? What's the input? What's the output? And we don't even think about maybe there's something in the middle. And we have to make sure you're answering the questions that they are asking. So when I look at page 51, question number 1, what is the output of that program? Take a guess. Okay, if you picked C, you're correct. The output is the sum of 100 and 200. It doesn't matter that they modified Z after the display. The display is going to be the output for the person. Question number 2 on the same page. It's a little bit different. It's the same program, but it reads, what is the value of the value variable Z when the program segment completes execution, meaning at the end? What is Z? Take a guess. You are right. If you pick Z is D, negative 100. By the end of the program, even though you displaying or the output was 300, the end of the program, your Z value is now at a negative 100. Okay, the next problem we follow is that do not follow PEMDAS. PEMDAS is the golden rule of mathematics. We need to deal with parentheses before we deal with exponents, and then we follow multiplication and addition from left to right, and then we follow addition and subtraction from left to right. So you have to make sure you're following PEMDAS. Try question number 3 and number 4. Okay, the answers are on the bottom of the page. Again, you just need to follow your PEMDAS. Concern number 3 on page 51. You need to understand what the idea of a random output means, or a random generator. The word random literally means anything, okay? But usually there's some types of limitation to random. So if you're looking at page 53, you're picking something for A, you're picking something from 1 through 10 inclusively. You're picking something from 11 to 20 inclusively for the value of B, meaning any number in between. When you're looking at that random component, you want to think about the extremes, like what is the lowest number that it could be, what is the highest number that it could be, because that's usually what the question is pertaining to. So try number 5 and number 6. The answers are on the bottom of the paper. Then last but not least, it is mods. Now, mods is something that some people have a hard time getting. Mods is just when you're dividing something, you don't really care about what the quotient is, but what is the remainder. That's what we use mods for. So some people have, it's a little bit weird to think about. You don't care how many whole, if I had, let's say, I don't know, 15 pieces of cake, right? And I'm going to split up the 15 pieces of cake amongst 2 people. It's not really important that I have 7 pieces per person. It's that we have the one left over. So if I had something like 17 mod 2 for 17 pieces and I'm splitting them up amongst 2 people, the answer would be 1 because I would have 1 item left over. So we're focusing on the leftover parts when you're thinking of mods. When you're thinking of mod, when I see something like A mod B, when I do the question on the side of my paper, and yeah, you're going to be doing some long division on the side of your paper. It's not a big deal. You're going to do B on the outside, and you're going to do A underneath the square, underneath the division sign. So B is on the outside, that's your divisor, and A is underneath the house, and it's the item getting split up. So when we come to class and we do some practice questions, we're going to do these practice questions in class on Wednesday. We're going to have some mods in there, or we're going to practice and go through some ideas of how to work with mods. Questions number 7 and number 8, the answers are on the bottom of the paper. If we want to go over 8 in class, I will absolutely do it. And I hope you're working on your create performance tasks.